Let me start. My name is Krob. I'm a security consultant based in Czech Republic, which basically means that I'm the one who is between the business and the security, helping business to understand the new challenges of security and help to survive this new challenge of security. So that's why this is a topic for me, how the post-quantum impact our business. And from the very beginning, let me tell, I'm not the super expert on quantum. I'm rather super expert on how to survive the security challenges. That's why I choose the topic, how to see the challenges, how to be able to manage them. But of course, it's about quantum, yeah? And it's not new, yeah? How many of you understand what the quantum risk means? Please give me a hand. Not much. Interesting. I've got a few introductions, which basically means that I will tell you what I understand is the biggest problem. But if you would like to go for the details, please refer to a presentation of Tomáš Fabšič from last year, because he was quite a good one, spending 30 minutes on describing what does it mean for the security and how the quantum computers can be a threat for us. Basically, for the others, simple words, we have got the encryption mechanism, which is somehow derived from the non-easily ability to factoring the large enough numbers. That's the case that right now, for current computers, it's not easily can be done. So we have got quite safe right now. We have got the encryption is completely okay for now, and at least for the last 20 years, we were quite sure that the security is there. The problem is that the quantum computers bring some new feature, which basically means that by way of calculating the things, they will be able to break those encryption in a minute. And that's the problem, because in that case, all my encryption, all my working with the current algorithm will be useless. I will be unencrypted right now, and that's the problem. What is the good news? That we have got attention. So right now, all the security world is trying to solve this problem, building up the awareness, and even in August, we are quite happy because we have got the 3 new algorithms which we can use, which is called post-quantum, means they are somehow quantum resistant, quantum risk resistant. So we have got in our hands right now 3 new algorithms, and we can use them. So from the quantum science, we are quite okay. Quantum security science, we are quite okay. The problem is how we will apply this to our system. And that's the challenges I would like to talk to you today. That was the good news, but also the good news is on other side. Also quantum, it's somehow evolving and progressing. If you will ask Gen AI, when the quantum risk will be a problem, the Gen AI, the open AI will tell you, okay, you have got something like 10 to 30 years, but it's quite hard to estimate right now. The security guys, including the authorities, is now estimating that in 2030, 2031, 2032, there will be a problem. So that's the case when we will be probably have got a problem in our system if we will not be able to have got the post-quantum cryptography. I'm using this sentence, we cannot afford to wait, to somehow waking up all of you to better understand what you need to do with your encryption right now, even that you understand that 2030, 2031, it's quite a time ahead. Yeah, because if we have got a 2024, and I'm thinking about what will be the security in the 2031, it's 7 years, so you need to think about what was the security in 2018. And in 2018, it was something like that we are starting discussion about XDR, the endpoint defender and other things. We are starting discussion on that OT security is also important. So, quite a good start. And we are starting discussion that our companies has got perimeters, but they will not be enough to secure. So in that time, 6 years ago, we were discussing that the perimeter, like the firewalls and other things, will not be enough to secure the world. Probably you are now understand that the perimeter is gone. The security is everywhere. So this was six years ago. So what will be the situation in 6 years? I don't know. So what are the challenges right now? And I will come to this citation at the end of my presentation. So still being pragmatic. And I'm the guy who is asking, okay, so it's still something that is quite new. You can see the quantum computer here also, but it's just a two qubits, so not a big one. You maybe also heard about the success of Chinese scientists. Five days ago, they declared that they somehow push again and break the asymmetric cryptography. So it's evolving, but okay, when it will be a threat for me. So is time ticking right now or not? Let's deep dive. First, it's not only the 6th year. Yeah? The problem is that we have got a threat we call harvest now and decrypt later, and I will give you more details in a minute. We also has got the experience that last time that we have got a problem with encryption, probably you also remember that it was the problem with MD5 and the SHA-1 and other ones, and it took like 5 and maybe 10 years to correct this. Even 10 years after having and well announced the problem with MD5, still some system on the internet using MD5. So it's quite hard to somehow replace the encryption in our system. So if you think about 6 years and you have got 6 years ahead, you need to be quite precise in case of how much you have got to replace your crypto assets in your system. What's the harvest now and decrypt later? Do you know this threat? Not much? Yes, once. What's the problem? The problem is that if you will be able to get the data today, you will not be able to break it, but you can store it as a data stream, keep it, and wait for decryption when the quantum computers will be mature enough. And probably you know that the option to store the data, it's not much expensive. So we need to take into attention this risk. So the problem is, especially with the data, which are confidential right now, but which will be confidential in the certain time. So the problem for the data right now will be in the future, because in the future you can decrypt it and you have got the something that today was confidential. The key point that is something like the mantra for understanding how much time I have got is this schema. And it's easy. Yeah? You have got the Z, which is the time when the quantum computer will be ready to break your encryption, your old encryption. Then you have got the X, which is the time that you need to take into account and your data will be still confidential. Your current data will be still confidential. And then you have got the magic Y, the yellow one, which means how much time you need to replace your current crypto assets. And if the X plus Y will be longer than Z, you have got a problem. The problem is that we don't know how long is Z right now. And probably, I'm not sure how you know your crypto assets, probably you also do not know how much Y time you need to be able to solve this problem. So let's continue with the questions. What and where? So the scope. How much of you somehow are aware of the crypto assets in your companies? Are you students or are you the employees responsible for security or for AI? Employees? Business? Perfect. How much do you think you have got the crypto assets in your companies? And it's the question. Let me share the example first. We are working with the bank who has got 2.5 million clients, small middle bank. And this bank has got something like the 8,000 crypto assets. So 8,000 certificates and keys. If you look at those 8,000, you will see something like the 4,000 of machine certificates, so usually managed by PKI. Those certificates you have got on your notebooks, mobiles, servers, and other ones. Out of the rest of those 400, you have got, they have got something like the 3,000 of self-signed certificates. So certificates that was delivered by some vendor, companies, maybe internal teams, to somehow secure some communication or secure some data, but it was self-signed because they need to have got encryption, but it's just self-signed certificate. So you don't have got much managed out of this. You don't know where those certificates are right now. You can scan them, for example, by the Nessus and other vulnerability management. You can see where those certificates are, but it will be quite hard to be replaceable. So out of those 8,000, you have got 3,000, which is a little bit out of the control. Out of this, the rest, the 1,000, it's mostly about some public certificates for the website, some also private certificates for signing the contracts for the clients, basically, and others the applications. So what do you think? How much certificates you have got in your companies? By the way, when we ask this company how much they have got the assets, they expect something like the 5,000. So the reality is quite bigger than you expect. And you will need to probably solve all those 8,000. Some of them easily, some of them not so easily. By the way, another our client, company who has got a lot of IoT devices, they have got something like the one and a half certificates, the keys that are securing the communications. So it's quite a big problem. Yeah? What do you need to do to understand better how big is your playground? You need to look at all those devices, applications, the databases, the platforms, the services, and try to somehow map how much of those crypto assets you have got. Yeah, you have got under control. If they are the based on your PKI, if you use the PKI and the issuing authorities, you are quite safe because you probably has got some evidence on how much certificates you issued. But certificates which are part of your application solutions, that can be quite a problem. Yeah? They are somehow hidden, and it's used on the daily basis. You can use your own tools. Probably most of you has got the vulnerability management, and they can be quite easily used for scanning the system. So you can see how much certificates are used by the services. You can also use some operational management tools to see how much keys are stored in your key vaults. You can look at the SIEM and look at the security operating system. You can even scan the network traffic and look at the certificates, which is completely hidden because they are somehow encapsulating in the applications. Yeah? Probably, by the way, they were the most important one because they are somehow securing your applications data. So you probably will need to replace them in some priority things. Yeah? For the threat harvest, now and decrypt later, it's more about how you work with the information, data assets, and the classification. If you already know the level of confidentiality, you need to just look at those data again with a new point of view, and you need to somehow think about the fade out of this confidentiality. So, for example, if you work with the client's data, a bank, for example, you need to think about if 5 years the confidential data from today will be probably still somehow sensitive, because it still represents some financials of the client, so you will need to probably also secure those. That's the case. Mostly it's about business and about regulation. For example, GDPR is also quite tricky in case of the personal data. So sometimes this X information can be quite big. And then, so you need to act right now. Because right now, if someone will steal you the data, they can be decrypted in the time. So that's the tricky part of this schema. Of course, you need to understand out of those two information, how big is the risk that represents those crypto assets. Because you will need it, because it seems even right now that it will be quite a big project to somehow replace all those crypto assets. So you need to do a prioritization to understand which one should be the first, not to break this XYZ schema. The key point here is also who should do it. Is it security problem? Or is it IT problem? Is it the business problem? So you need to understand who should do the replacement and who should probably pay for this. And that's the critical part, because probably you right now also understand that the new algorithm will be implemented by the vendors. But probably new algorithm will take more performance in case of being executed. And believe me, if you will look at the standard direct channels or standard portal application, you will see that we have got a lot of encryptions there. And sometimes the applications are not so optimized. They are now in the working state. But if you will enlarge the key, you will see that all those milliseconds will count into the crazy situation when you will not be able to execute or to operate the application again. So it's important that you understand that you will need to use the new algorithms, new keys, but you need to do a lot of performance testing also to better understand. The interesting part is the vendors. And frankly speaking, a lot of vendors, even before the August, declare that they will be able to work with the good candidates of the encryption. So they are even now working on the implementation of these new algorithms into their solution. What's the tricky part is, and it's always the tricky part, that if you will not fit the life cycle of your system, so if you will not fit the investment time that the old software, old application can be replaced, it will cost you a lot of money. So you need to somehow be able to plan properly the changes, probably also do the joining replacement with some other features to be able to be still affected from the financial point of view, and somehow avoid this cost creep effect. Otherwise, you will be probably target of the very good proposal of the standard platform vendors, which will give you all new hardware, all new software, which will be probably unfeasible in case of money that you will need to pay for it. Also, the big problem is, the solution needs to be also found with your internal development team. Because in case that you don't have got someone who is responsible for the overall application, you need to build more awareness and probably also resolution the system that is internally developed. Here you need to probably do the good awareness and already testing the system that will be quantum resistant right now. Of course, you need to understand the timeline of the solution, and you need to be quite smart in case of having the options. Because I expect, and we will see, it will be a lot of options how to replace it. It will not be just one crypto solution. You can leverage a lot of solutions that will help you to be quantum resistant. How to do it, and that's the way when Accenture has got a nice methodology. And I think I already mentioned at least two steps here. What I see right now, at least from this, from our experience, in most cases we are still in the discovery phase, not the phase that do the implementation. It tends to be quite a complex project. It's not about big changes. It's more about big activities in case of the number of the activities. And the problem in most cases is that you need to find the way how to not approach the big bang situation, because sometimes you would like to change the systems, and you see that you need to change one more system, which tends to turn into the big bang replacement, which is probably not feasible. So that's why we are now rather discussing on iteration. We are now discussing and defining the minimum compact set of components which needs to be changed, and rather experience the iteration when you are learning out of the previous iteration on the way how to replace the keys. The journey. Right now, we have got something like the eight steps. I don't want to much go into details, but you see that you have got the discovery phase with the understanding of the risk, with a big roadmap, which will give you the overview on how much time you need to have got for the implementation. We are leveraging this XYZ schema, at least to understand when we have got the time to somehow wait for some changes, because we would like to be part of some bigger release and other things. So that's the best strategy how to make these things feasible. What's also important, and I did not manage it, I didn't mention it, when you will look at those changes and understand how hard those changes are right now, it will be about the way that you will probably not want to do it again. Yeah? So you are now even thinking about how to make those changes repeatable or easily repeatable. Because right now, if you are asking the IT to replace the crypto assets, you will challenge the situation where they all do it manually. So they will just replace one by one, and if you have got something like the 8,000 of the keys, 4,000 will be changed by the Microsoft. You still have got something like the 4,000 certificates that needs to be changed one by one. That's why we are now seeing the new category of the system. It's called PKR, or key orchestration system. So that's why the system will help you to somehow manage the certificates within the key vaults, and will help you to easily replace them by the automating procedures. So that's why managing the certificates is also important, because then you will save the time to do those replacement changes again. So if you are looking at all those changes, and I'm just now summarizing the things, the time is ticking. It's completely dependent on how you will count all those XY things, and how the Z, the Q day, how soon the Q day will come. So it's up to you to understand the scope, where you have got those crypto assets, to understand how much those crypto assets will take you to replace, how much you will be able to get the support from the vendors, because some vendors will be ready in the month's time, some vendors maybe will be ready in the year time. So you need to somehow leverage also the preparedness of the products that you would like to replace. You will need to take into account the costs also. So trying to find not also the vendors that are now your delivery guys, but also finding the way how to maybe encapsulating the crypto communication, how to maybe look for the way to find more compensating controls in case of this. That's why you are forced to have got the risk management from the very beginning to understand better if the costs are somehow balancing the risk of this encryption. And you need to do it smart. Means you need to find a way how to all those small but many changes do in a smart way. Do it in an iterative way, not suffer from the big bang, trying to maybe identify the system that are priority for you and change it in the one release, and learn out of those release for the future iterations. Of course, there will be a situation when you will not be able to change because some legacy system will be not able to change the crypto assets there. And it's common situation. The good example is the old IBM AS400, when you have got, even now you have got the keys which has got the one key length, yeah, which is crazy even now. So you need to find a way how to somehow encapsulating or somehow build up the compensating controls that will help you not to have got the exposition out of this system. So from my point of view, and I see it as another bad present from the security. I see that the infrastructure, this all will be quite a big transformation. And believe me, it's unexpected. Right now, the IT is working on cloud, is working on AI. Expect that you will not be beloved if you are a security guy. That another transformation needs to be executed in maybe 2 or 3 years. So that's also the aspect that needs to be taken into account and somehow be able to automate as much as possible and help IT to survive this nice challenge. Coming back to and this is my final slide, coming back again to the citation from FS ISAC, which is the FS organization worldwide, has got a nice paper discussing the problems of the quantum and post-quantum cryptography here. I think we really cannot afford to wait right now. What we recommend to our clients now, it's at least to understand how big is the problem on their premise, how much crypto assets they are using right now, do the discovery phase. Yeah. In most cases, you can do it by your own tools. It's easy. You're just using your SIEM, vulnerability management, and other things just to understand how big the problem is on your side. And XYZ. Yeah. If the Chinese scientists will be faster than we expected, I believe that the Z can be even lower than 6 years. Right. Thank you very much.
Thank you, Jan. And we have a couple of questions on a Slido, so let's go to Q&A part.
Can you please tell more about the MD5 problem? Because it's really still widely used for data encryption. It is, and it is crazy. Yeah. Remember, I'm not sure if you know that the Mr. Klima and Mr. Rosa from Czech Republic was quite included in finding the way how to break the MD5. And those guys were quite young in that time. I think it was 2005. Maybe someone can help me. And right now they are quite, Mr. Klima is quite the retired guy, and Tomáš Rosa, it's part of the Raiffeisenbank right now. So frankly speaking, tell me more about the problem of MD5. Whew. I wonder if we will be able not to repeat this problem again in this post-quantum. Because I expect that when the quantum computers will be mature enough to break the encryption, all the regulation, all the governance agencies will be hunting those companies who is using still the old way of encrypting, and will give you a lot of problems. Did I answer the question? Their harvest now decryptor. Who to bother about 5+-year-old secrets in times when buzz is about RT data and half time of the data value is measured in days, if not hours? I think it's more about the business, and that's why I'm telling that if you would like to bother harvest now decryptor, you should focus on the business data. Yeah, and I believe that I'm not sure if you have got a salary today, and I'm not sure if you feel bad if in 5 times it will be publicly available your salaries. So think about yourself also, and that's the real example from the business. Maybe in case of GDPR, frankly speaking, I believe that still something like the 10 years ago, what I did 10 years ago, it's still very sensitive for me. So I believe that it's not the RT data, it's not probably not the IP data, it's not the operational one. I think we need to focus for the data which has got some privacy value. And I believe that will be those that will need to be somehow secured in case of even the years, 5+ years. By the way, the 5 years, that's the estimation of the Czech security agencies. Yeah, they said, okay, we can roughly say that still the retention or no, the confidentiality fade out, it will be in the 5 years. But still, think about your own salaries. Yeah? I believe that that's a good example. Do we have got available any special hardware acceleration already in order to handle the increased CPU need for Q-safe algorithm? I'm not sure. I'm not sure if it is the matter of some hardware acceleration. I think it's more about some unexpected summary of those performance problems that you have got right now. And I really have got a good example from one of our clients, and they did not change for the PQC. They change only the length of the keys, and they issue, I think, from 1K to 2Ks, and they do it easily within their direct channel banking, and they do all the tests, and it was completely okay. And then they opened the business on Monday, and in the 1 hour time, the channels was gone. The problem is they do not know where was the root cause of the problem, because you have got so much small actions and encryption in this system that you don't know where those thresholds is somehow growing too much, that some other system or some other services it's going mad on this. It's like DDoS, yeah, in case of this. And even now they did the rollback, by the way, yeah, and they are now focusing really also on the performance testing. But I believe that even now they don't understand where was the root cause of this problem, because there was so much communication between the servers, there was so much encryption activities that you don't know where you are losing the performance and how the performance is counting in case of this. Yeah. So I do not expect that we will have got something like the special hardware for using the new system, new algorithms. I believe that we will need to build a better systems. Yeah. Better performance, more CPUs for the things, maybe optimize the communication, because frankly speaking, sometimes it's just a problem with the architecture of the system. Yeah? Because if you are encrypting each, let's call it packet or business data packet, and you have got it something like 1,000 per second, you have got also the problems because the performance cost that you have got with your PQC algorithms will be something like 10 times something more. So if you will align the architecture and you will send just one packet for the 1 second, you will have got definitely less impact on this. So it's not only about buying a new hardware or having a better CPU and better performance on the cloud. It's maybe also about paying some technological and architecture debts that we have got in our applications. That's why whole this situation, it's the job not for security, but most of the time for the architecture guys, yeah? To understand better how to smartly replace, and maybe also how to optimize the using of encryption. How can it be guaranteed that algorithms thought to be quantum safe are actually quantum safe? What would be the consequences if they in fact weren't? Of course it will come, yeah? Of course, that's why we are now taking into account also this manageable things. So if you are doing right now a lot of replacement and you are doing this manually and you expect that you will need to have got something like the quantum square new computing method to expect that you will need to change the algorithms, you are probably doomed. Yeah? I think you now need to prepare the solution that will help you to replace the situation more in agile way. And that, by the way, the depth we have got, the technology depth we have got now for the crypto assets. Yeah, fairly speaking, who are aware of the crypto assets in your companies? You know how much servers you have got, you know how much applications you have got. But sorry, it works so well that it's completely transparent for us. Yeah, and right now we have got a problem. Right now we need to do evidence. We need to replace them. So if you are able somehow during this process make it more orchestrated or make it more managed, wow, that's the way. Yeah. So of course expect that the algorithms will change. That's the dynamicity of the security. But then you probably will have got a system that will automatically replace the algorithms. Even now, it's not only about the algorithms, it's also about using the old algorithms and the new algorithms. So right now, maybe you have got in your head that you have got a certificate and the certificate has got just one key. Maybe it's not practical one, because then the user, the guy who is using your application will need to have got a lot more keys, because one key will be the old one for the legacy system and one key will be the new one for the new system. So right now also in this discussion is that we have got this some kind of hybrid containers that will have got the more than just one key, and the application will choose which key will be the relevant one. So you will be able to do this transformation smartly, not in a big bang, but you will be able to use the old applications and also the new one. So I believe that this is the answer. Yeah, we can and we will expect that it will be a problem in those algorithms. So I expect that that should be dynamically changed. Isn't it important to help everyone with moving to new encryption standards for free with help of government? Most people would not want to pay for switching some buttons in device settings, especially elder ones, which will put them in a big risk of losing their privacy. I believe that we have got at least two questions here. First, I think the citizens will not be much affected, because I think this is the challenge for the companies. So I believe that even the elder ones, it will be transparent for them. Maybe they will need to change the application. Maybe the application will be changed automatically. Yeah? If you are a company and you are now using the old application, sorry, it's your business that you need to be able to replace for the new one, because business, it's something that is part of your business. I think how the government can help us is some regulation, and we can see it in Czech Republic. For example, NUKIP released something like the advice on the PQC, on the algorithms and using. They are expecting that the companies which is under supervision of NUKIP needs to be quantum resistant in, they say, expecting 2027 or 2030 or something, but it's still advisory. And I believe that the authority that I just mentioned was also quite a big help. Yeah, we have got the algorithm right now, NIST invest a lot in here. I believe that EU will also invest a lot. I believe that at least on the national level, the agencies will coordinate the replacement. But I don't expect any investment that the government will do in such a cases. Can you imagine scenarios where non-quantum vulnerabilities will be emerged in future quantum-resistant encryption algorithms? What does it mean? So we will have got the future quantum-resistant algorithms, and then we will be able to see some vulnerabilities which will not be quantum-driven, but which will have got some other problems. Is this the question? So, of course, we are living. This is our world, right? In security, this is our world. Yeah. Expect how much black swans. Do you understand what does it mean, black swans? Something unexpected. Do you see how much black swans we have got in 3 years? COVID, big shift. Closing of perimeter. Our data is everywhere. At home and home PCs. With the crazy VPNs, with the guys who is working on the work computers with their kids and everything. Ukraine and the cyber. Big, huge thing of ransomware, of some activities and everything. Then we have got, what we have got? A lot of Log4j, I'm not sure if you are aware. Log4j, another nice, quite wide problem with a lot of things. Then we have got a CrowdStrike. Wow. Believe me, I think that's our business, right? I'm not sure if you are a security guy, but we are living day to day and we expect everything. Yeah, that's why the Z, it's quite a question mark. Yeah, because when the Q day will come, we don't know. But there are so much money in there that I expect that the quantum will progress much faster. That's why we are now threatening you, our customers, that you need to start to at least understand how big the risk is for your organization.
Thank you, Jan, for your presentations.